Welcome back, my friends. In this video, I'm going to talk to you about the two toolkit functions that I talked to you in the last video, the reciprocal function and the reciprocal squared function. These are both rational functions. I have a polynomial, the constant polynomial 1 in the numerator of both of these functions. And then for the reciprocal function, I have the polynomial x. And for the reciprocal squared function, I have an x squared polynomial in the denominator. So we have these rational functions here. And I think it's going to help us the most if I show you on Desmos and we can talk a little bit about these two functions. And I'm going to introduce to you some notation that's going to help us talk about them. And then we'll do some graphing. So here we have the reciprocal function. F of x is equal to 1 over x. And so you'll notice I have these dotted red lines here. These are asymptotes. I have a vertical asymptote, which is going up and down. And then I have a horizontal asymptote, which is going from left to right. And what makes these asymptotes is that my function actually never touches this vertical asymptote. Notice the function's increasing, 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 and you might be tempted to think, look, Sarah, it looks like they're overlapping and like they touch here. But if I zoom in, you can see there's actually a little bit of space in between the blue line of my function and my red asymptote here. So I hope you're able to see that clearly. And so this function is a little strange. I have the left, sort of the left and right, or there, it's kind of split up by these asymptotes here. I have only, the function is only existing in the first and the third quadrants, and it doesn't have any points anywhere else. We have this function here. So let's take a look at a table of values. It's going to help us understand a little bit more about this function. So here we have right below the blue function, we have this table of values. So I can see that when x is equal to -2 at this point here, that we have y is equal to -0.5. And that when x is equal to -1, we have the point 1, -1 comma -1, and so on. And just in general, as we get closer to 0, right, I'm starting off pretty far away from 0 here at -2. And as my x value is getting closer and closer and closer to 0, my output is getting smaller and smaller and smaller. And that's what's happening when I get closer to 0 from this left side of my graph. But what about from my right side of the graph? What happens as I get closer and closer to 0 there? Well, as I hit these points, I also get increasing values. So as I get closer and closer to 0, but I'm coming from the right-hand side, my function is increasing. So let me give you guys a little bit of notation here, so we can mark it up. So as I have my x values, are approaching 0 from this side of the graph, from the left-hand side, to show that it's from the left-hand side, I'm going to do that little minus sign there. So as my x values were getting closer to 0, what was happening to my output? Well, my output was going down towards -infinity. It was decreasing very rapidly. So that's what was happening as I approached the left side of this graph. And as I approached 0 from the right, so as my x value approached 0, and then this little plus means from the right side of 0, my function output, f of x, got larger and larger and larger. We approached positive infinity. And so that's what this notation means here. You would read this as x approaches 0 from the right. That's how you would say this. You would say as x approaches 0 from the right, f of x approaches positive infinity. And as x approaches 0 from the left, f of x approaches -infinity. And what you're describing here with that notation is you're describing this vertical asymptote. You're describing what happens here. So this is one example. This is our reciprocal function. Let's take a look. Let me turn this off here, get rid of that. Let's take a look at our reciprocal squared function. That's this one. I don't know if you remember seeing that before. And I want you to think for a second what your notation would tell you here. Like as x is approaching 0 from the left, what's your output doing? And as x is approaching 0 from the right, what's your output of the function doing? So take a second and see if you can use that notation and describe this function. And I'll check it for you. So take a second, go ahead and pause that video and see if you can write down using the notation we just introduced. You ready? All right, so let's check. As x approaches 0 from the left, f of x is approaching, you guessed it, infinity. And as x approaches 0 from the right, f of x is approaching, you guessed it, infinity. And that's what we have happening here with the reciprocal squared function. And this can actually help us to graph a few functions here. So let's focus. I'm going to get rid of these tables here so we can have a little bit of a cleaner look at our function. So let's suppose I wanted to graph a transformation of this function. I wanted to say, look, let's take my new function and let's move my reciprocal squared function vertically up by 2 units. And I wanted to move my reciprocal squared function horizontally by, let's say 2 units. So I would say this will move my function horizontally by 2 units and vertically by 2. Ooh, I made it f of x, but I wanted to make it our reciprocal squared function. No worries. We'll just change it to g of x. G. There we go. So you can see our new red function here. I just shifted it. And notice too, our vertical and horizontal asymptotes don't match anymore. They don't match anymore, but that's okay. We can do that. So I shifted vertically my distance up of 2. And so all I have to do is shift that vertical asymptote up by 2. Same with my, oh, sorry, I said vertical asymptote, but I meant horizontal asymptote. Same with my vertical asymptote. I shifted horizontally to the right by 2, so I can shift that to the right by 2. And you can see that I still have that asymptotic behavior. And that would shift that function. And by the way, if you were curious what that function would look like, if you just witnessed it without using the g of x notation, you could say, look, Sarah, that's the same as h of x is equal to 1 divided by x minus 2 quantity squared plus 2. And that would be that function. So you can already use some translations to help you understand how to graph rational functions. And that's kind of something going back to the last section. All right. I wanted to talk about domain and range, but I think I'm actually going to save that for the next video. I think this is quite enough for you to tie on. And I'll see you guys in the next one.